Hello, and welcome to another episode of On Point. I am your host, Josh Porter, and today we're going to be talking about a subject that is near and dear to my heart, and that is engineering forensics, and specifically talking about junk science. So, before we jump into this particular case that we're going to go over, this is from about 6 or 7 years ago. I wanted to go ahead and set the stage for you. So, if I look off to the side, I'm trying to read through some of my notes, make sure that I stay on top of everything for you. Okay, so imagine you own a home here and down here in Florida where we're at, and you ask your neighbor to watch your house, and then you get a flight and you fly up north to your northern home. This is a common scenario for a lot of snowbirds that we call them, where they come down here and they stay in Florida in the winter, and then they go back up north during the summer. Well, 7 days after this gentleman, this client, and I'm going to keep all of the names redacted, and I'm not going to use any names, and I've redacted all the data from other engineers and stuff like that, so nobody gets in trouble. But imagine you leave your house, and like this gentleman did. 7 days later, the neighbor comes in and says, "Oh my gosh, you've got this huge problem. You've got water everywhere, and it stinks, and you've got this water leak." And he goes and shuts off the water, gives you a call. You call the insurance company, right? Well, this guy, this client of mine, he had the flight tickets and he had the phone records and everything to prove that that he had left on day one, and that his neighbor checked in on the house and called and then he called the insurance on day 7. Well, it seemed like a open and shut case for insurance. So the client calls the insurance company. Insurance company calls an engineer out. An engineer comes out and looks at the house. The engineer writes a report, and then the insurance company tells my client, the homeowner, that we're not going to pay for anything. The house is pretty much totaled as far as the interior finishes and drywall and everything. I'll go through that and show that to you. But they basically say they're not going to do anything. The insurance company's attorney files what's called a motion for a final summary judgment. So they're basically trying to get the case dismissed, because he had to sue the insurance company to even try to get any money. And then that's when I get involved. Ideally, I would like to be involved sooner than that, obviously. But again, I think my client and his attorney felt like this was going to be a case that should be pretty easy. I mean, they have home insurance. That's why we all buy homeowners insurance, to help us out when we have these problems. So they call me out and they say, "Hey, listen, we've got this problem. They're not going to pay. They're trying to get our case dismissed in court, and they've got this engineer's report that shows or that they're using as an excuse for not covering my client's claim." So what I'm going to do is I'm going to show you some of the damage that occurred inside the house. Now, again, I'm getting involved several months later, so you need to kind of have that perspective as well, and so did I when I was working on this case. So here's the picture of the main room that was the problem. It was a pipe in the bathroom that had burst. On the left side of the picture, you can see the bathroom counter. There's a gentleman standing there in the picture. I didn't crop him out because I wanted to make sure I maximized as much as I could see in this picture, and I didn't have any pictures without him standing in it. So anyway, so you've got the bathroom counter on your left. There was a pipe on the wall just behind that burst and sprayed water across the side of the wall. And we're talking about this wall. We're talking about the wall with the studs here. Let me see if I can draw. Okay, so we're talking about this wall right here. Okay, so that wall was completely sprayed down with water. Before I got there, that wall apparently was so bad with mold and water damage that they had removed the drywall from those studs. And then you can also see that the door to the bathroom has been taken off the hinges. You can see those hinges there in the picture, where the door has been taken off. Here's the opposite side. So now you step into that room and you turn around and you look up above that door, and you can see what we call like a halo. It's a discoloration in the wall, where you can see where the water was spraying this sidewall. It was kind of spraying over here onto the sidewall, but some of it sort of splashed on over to the wall above the door. So that produces this like halo effect, and then you can obviously see some discoloration up here at the ceiling as well, from mold growth and humidity in the unit, or in the house rather. Here's the door. They went ahead and removed it. This is a picture of it just to kind of give you an idea how bad this was. I mean, this was a lot of water. The pipe that also burst was a hot water pipe. So the gentleman did not turn off his hot water heater, which you're not required to, but he didn't turn it off when he left. So the hot water heater's full of really, really hot water. And it's just spraying like a mist, this hot water all over the wall and all over the door. And you can see how it ran down the door and all of the mold. That's like, this coloration isn't rust that you're seeing on the door. This is actually like mold that had, and mold spores that had sort of followed the flow of water down as this water was running down the door. This is the adjacent bedroom. So a little bit of water came in here on the floor from this water, and that's why they removed the carpet and the tack strips. You can see the tack strips for the carpet are gone and the baseboard's gone. But you can see that the water really only touched the baseboard because it kind of flooded about a half inch or an inch or so inside the house. But you can see mold spores all over the walls, right? So we know we have this environment of just incredibly high humidity in this house. This is another room over, further away from the area, and you can see they removed all the carpet in there, but they left the baseboard. So this is sort of getting to the extent of the damage. The room beyond in here, this is the master bedroom. It's literally the only room in the entire house that didn't suffer any immediate contact damage from water flowing into it. And this is a picture of one of the kitchen cabinets. You can see the kitchen, the base cabinet in the kitchen sort of, got all swollen and swelled apart from absorbing that water and was severely damaged. All the cabinets were shot and damaged in the house. And you can see the water staining and some of the mold back here in the back area on that where the baseboard was removed. All right, and so this is our culprit, right? This is the this is what caused all the damage. Is this pipe? This is here's your one of your cold water lines, and this is your hot water line, and there was a small hole in the side. I didn't show you the picture of that. Prior to me getting there, it was already repaired, and they put on this what we call a shark bite fitting. So they had already fixed the pipe. But there was a small hole on the side of the pipe. Now, I'm not going to get into the technical merits of the hole. The engineer and the insurance company claimed that the screw from the light fixture somehow went into the pipe like sideways or something. I don't know. I debunked all that nonsense. But the reality is that that's not really what we're going to be talking about today. So what we're talking about is the engineering firm that was hired by the insurance company. They came out and they produced a report. And I'm not going to show you the whole report. I'm going to show you just this one section of this one page. This is the heart of the report as far as I'm concerned from an engineer's perspective. And it's essentially the meat and potatoes of what the insurance company used to deny the homeowner his claim. So in the first bullet point here, we can see that they're saying something about the water meter, and they checked a couple invoices, and based on that, based on the amount of water that was used that month, they believe that it has been leaking. That pipe had been leaking for a minimum of 23 days. You can see where I highlighted that, okay? Then based on Stachybotrys, this is a type of a mold. So based on the amount of mold we saw in our lift samples, we believe that the water had been spraying for a minimum of 2 months. All right? Based on a carpet tack strip material and the way it deteriorated, we think that the water has been there for at least 51 days. Whoa! All right, so this pipe in this wall has been spraying for 51 days now, according to the engineer. What we start seeing now, too, in this report is they now are comparing. They're saying the documented carpet tack strip, okay, carpet tack strip material, okay, corresponded to a duration. Now, what they're saying is that they're referencing something here. They're saying, compared to this reference that we have over here, the carpet tack strips and the color that it was when we got there, and that engineer got there way before I did. But comparing these two things, it shows a 51-day moisture exposure. And here you can see these pictures. And here, photo 1 down here, okay, we're looking at the discoloration of the carpet tack strip, and the photos aren't very good, but this is the quality I was given. And so based on some study that was done, scientific study, it looks exactly like the tax strip from day 51. Follow? All right. So when you're doing this and you're writing an engineering document and you're writing and you're citing a scientific research article or a scientific journal, or you're citing anything of authority, you put in these parentheses and you cite it and you put the date and of what your scientific reference is. Then as we get down to the bottom here, you can see they start then taking moisture measurements of the kitchen cabinets and the damage to the kitchen cabinets. And they're saying that based on the moisture measurement and the bump height, okay, I kid you not, because of the bump height on the cabinet, that this place has been exposed to water for at least 34 days. All right, so we've got 23 days, we've got 2 months, we've got 51 days, and now we've got 34 days. And then the last thing they say at the very bottom, it says the deterioration and stains documented on the baseboard located throughout the residence correspond to moisture. Again, we got that word corresponded, okay? So they're comparing it to this scientific journal here, this whatever this scientific is. I redacted the names of the people who wrote the scientific study. But they're saying corresponding to that, this water has been spraying out of this pipe, and this unit and this house has been subjected to water damage in excess of 81 days. So the first thing you can notice, there's a problem here, right? Why would the mold, like if they have all these scientific reports that they can reference and go back to, why does the mold show a minimum of 2 months? Why doesn't it show a minimum of 3 months or 4 months? Because down here at the bottom, they say it's been bad for 81 days. So there seems to be inconsistency anyway, but you can say, well, they kind of covered their butt because they keep saying minimum of, or they keep saying it's greater than 51 or whatever, right? So you've got this idea where they're just saying, well, we know that it's at least been bad. The lowest number you can find on here is 23 days, all right? And why is that important? Well, let's back up a little bit real quick and talk about what these citations mean. When you quote something and you quote a scientific study or you quote anything, you're supposed to put it in parentheses and then you're supposed to reference it at the end of your report. So an example of this is, and I grabbed this off the internet, but here's an example real quick. It says, teachers who connect classroom learning with students' daily interaction with music can better serve students' needs. Now, is that an opinion or is that like a scientific fact? Well, if you want to add weight to it and you want to say this isn't just my opinion, but this is backed up by some sort of science or study, you're going to cite some sort of scientific source or you're going to cite some sort of journalistic source. So in here they cite Adams 64. It's just an example, right? But then at the end of the report, you've got to then have a citation of that reference and where you're getting that information. So here they put that citation. Okay. So in our case, the engineers who wrote this document did that. They have their parenthetical citations of who the authors are and the year, and then they go ahead and cite that under the references. All right. And I had to redact a lot of that out so that nobody got in trouble. But you can see, one of them is a lecture that some guys gave at an international conference on indoor air quality and climate. And another one was an article they wrote for a magazine. All right, so these aren't peer-reviewed scientific deep dives into air quality and evaluating moisture damage and things like that. All right, so what they're doing here is they're doing what's called an appeal to false authority. And I'll tell you why in a second. So the idea is that first thing is that they are, well, let me actually back up a little bit and tell you what's really unique and interesting about this. When you're reading this engineer's report and you look at these references and you look at the citations and you look at the science, to the average person, you would say, okay, well, Josh, they're quoting scientific journals, they're quoting scientific studies. So, how can you refute that? You're basically just going to argue from ignorance. So what I do whenever I evaluate these things, I always just say, okay, well, let me look at the scientific studies. Let me look at the scientific journals. So I went and found these two documents, and I read them. And as I'm reading them, and we'll get to the merits of the science a little bit. But one of the things I found that was really interesting was that the gentleman that they quote as scientific references and studies, and here's names. Yes, I redacted them all, but I'm kind of just circling in general where their names would be. These gentlemen are the people who wrote the report. Or I should say, and they are also employees of the same company, the same engineering firm. So essentially, what you're doing is it's as if I wrote an opinion piece and published it in a magazine, and then later, for an engineering report, which is going to go to court, I then quoted myself as a scientifically proven source. You see the problem here? So what this ends up being is what we call an appeal to false authority. And the definition of that is a fallacy used when a person uses a false authority as evidence for their claim. So what they're doing is they're saying that because we wrote these things somewhere else, and they were kind of shady about the way they did this, the authors of the engineering report were not the same people who did these studies, but they all work at the same company and they all kind of did them together. So what they're doing is they're saying, listen, we are authorities on this thing, and then simply because we say so, and then we're going to quote ourselves, and we're going to let the average reader who reads this think that these are legitimate scientific scholarly journals that we're referencing, when really we're just referencing some stuff that we did ourselves in our garage with a spray bottle, literally. All right. So in order for me, to make sure that I don't fall into the trap of some other false argument, arguing against somebody because they lack a false authority, and I want to make sure I always argue the merits of somebody's argument. And this was something that Aristotle, I put a picture of him on here. This is something that Aristotle is attributed with pointing out this, and I'll put it in layman's terms. But this distinction between arguing with somebody on the merits of their argument and then arguing with somebody based on some sort of perceived authority. So, for example, we could be arguing about how to deal with income inequality, and I could say, well, I'm an economics professor, and you are not. You are a contractor, and therefore, because I know so much more about this, my argument is right. Instead of actually arguing the merits of the argument, you're just saying, well, I'm smarter than you. So I want to make sure I avoid that. The ad hominem based on false authority is an argument against someone's argument because they lack a perceived authority. So what we're going to do is we're going to now dive into the merits of their argument. So what they've done in the engineering report is this engineer cited themselves and said, because we have these examples, and what they're doing basically is they're saying, look, this study shows that a tack strip, okay, which is a little wooden strip with tacks on it that you stick carpet to, because this tack strip looks like this in this study at 51 days, and because our tack strip looked like this, then that must mean that our tack strip has been subjected to water for 51 days. And so what I'm doing is I'm going to go and look into the scientific study that somehow proves that tack strips can get to that color in 51 days, right? So here is an excerpt. It's kind of a wall of text. I'm going to break it down for you. And so here's an excerpt though from the study. So I went and found their studies. I went and found the method that they did this at. And this is an excerpt from the method of how they performed the scientific research study that they did. So it says, during the study, the moisture content of the carpet tack strips ranged from 7 to 16% for the dry cycle and 23 to 38% for the wet cycle. Now, I've read the whole thing, and there's nowhere else in here that tells you how many days they left it dry, how many days they did the dry cycle, how many days did they do the wet cycle, what percentage of the time was it 23% versus what percentage of the time was it 38%. I mean, there's just none of this information is there. How was the water applied? Essentially, it was applied with a spray bottle. They say that in the study. So they just went up there and squirted water on it. And then they used, and it says it further down here, a Tramex penetrating moisture meter. So this is essentially a handheld probe. So you've got a guy, some guy presumably coming in and spraying these things down with a spray bottle. And then you got some other guy coming in with a Tramex moisture meter, and he's testing the moisture content in the wood in their garage. And then they kind of come back the next day and they take more pictures, and they do this every day. And there's no what we call scientific controls or constraints to control for any variables. For example, like, you come and you spray with the bottle. Well, how long does it stay in that wet cycle? How quickly does it dry out? None of this stuff is really captured in their report or in their study. So anyway, it goes on to say the relative humidity was maintained between 37% and 47% for the dry cycle, and 63% and 84% for the wet cycle. Now, I can tell you right now, I'm in an air-conditioned house office, and in Florida, we run air conditioning all the time. And right before I sat down to record this, I went and checked the humidity in our office. I used my own humidistat, and I just went ahead and looked at the thermostat as well, and they were within 1% of each other. But it's 73% relative humidity here in Florida. Now, that's comfortable. I'm not sweating. That's pretty much typical relative humidity here in Florida. So what they're saying is that during the wet cycle, they were between 63 and 84%. Well, that's a normal air-conditioned house or bedroom or office. So how fast are you going to grow mold in an air-conditioned building? The answer is not very fast. And then they say that the relative humidity was between 37% and 45% for the dry cycle. I mean, you've almost got to be running a dehumidifier here in Florida to get 37 or 45%. So something's really strange about the way this test was produced. And again, we run into the same problems. Well, how long was it 45%? How long was it 84%? How long were your wet cycles? How long were your dry cycles? All right. And then it says the temperature, was held relatively constant for both between 73 degrees and 76 degrees. That is very comfortable. That's basically what we set our office temperature to here in the office to work. So this must have been an air-conditioned garage that they were conducting this study in, not a house where my client's house was. He set the thermostat to 80 degrees before he left, and it was actually in the engineer's report when they showed up 3 or 4 days after he called the insurance. The engineers show up, and the AC thermostat was still set to 80 degrees Fahrenheit. All right, so and that's a pretty typical thing that a lot of northerners do. A lot of what we call snowbirds, when they leave Florida to go back up north, they'll set their ACs to 80 degrees. I mean, I think they should be set a little lower, but they set them to 80 degrees to try to save energy, right? So then it goes on, it says the changing appearance of the test strips was photographed and compared to controls, no moisture, okay? These would be the dry cycles, I guess. I don't know. But they don't really explain how they do that. Moisture measurements were obtained, using the moisture meter. We talked about that. Sections of olefin carpet covered the test strips, and a cotton towel was placed beneath the strips with tap water added to maintain moisture. During the dry cycle, the tack strips were removed from their covered plastic container and allowed to air dry. Again, no durations were given at all. But here's your design constraints. The wood that got wet, it was maintained between let's see, you've got, I'm gonna try to erase all this stuff here real quick so we can focus just on the numbers we care about. All right, I'm gonna teach you something real quick. All right, so the wood was kept at a wood moisture equivalent moisture of 23% to 38%. During the wet cycle, the relative humidity in the air was 63 to 84%, and the temperature was 73 to 76. So this is an air-conditioned space, essentially. And 23 to 38% is not that wet at all. I mean, usually, if I'm testing something that's been submerged or in water, I mean, it's through the roof. It's over 50%, and we consider that saturated. So 23 to 38% really isn't even saturated at that point. It's very wet. We call that very wet, but we don't call it saturated. So they're using this study. So remember, this whole wall of text that you're looking at right now is from the study. They're using this study, and they're saying, now the house that we're going to go walk into, if I look at a tack strip in that house, I can compare it to this study. Except the problem with that is that the house doesn't represent what was going on in the study. I mean, the house already, the temperature was set to 80 degrees Fahrenheit. You have a hot water pipe that burst and is spraying like in a particularized spray across that wall. And we could see that with that halo effect over the door and the water running down the door in that previous picture. So we clearly have at least a substantial period of time where we have a relative humidity of 100% in the air. Essentially 100%, you can think of 100% as creating a fog. Well, think if you're taking a hot shower and it's like fogging and misting in the bathroom, that fogging is 100% relative humidity. So you can imagine when you have a hot water spraying, there's no cold mixing with it like in your shower. So I mean, it is hot, piping hot. And this thing's spraying in an aerated fashion across the room. You're going to create almost like a fog inside the whole house. You're going to jack the relative humidity way over 84%, at least 100%. And yes, you can have more than 100%. And that's how you end up with that just all the walls getting saturated, mold growing everywhere that we saw in the previous pictures. And then of course we also are dealing with a house where this water settled and flooded the floor. So you have an inch of standing water, 2 inches of standing water. So you have tack strips that are completely 100% saturated and submerged in water, which does not compare to the 38% that they used in this study. So nothing in this study is usable to compare to what happened in the actual field. So that is the crux of the problem, in that once I realized this and I pointed out that essentially the other engineer was one, arguing from a position of false authority, and two, that the scientific work that they had done was non-scientific anyway, and then that three, the scientific work that they had done doesn't compare to the design constraints of our actual problem, I was able to thoroughly debunk the whole nonsense that they had written. And the client was able to get coverage. Now here's the problem. Remember back when I was just saying that and here's why I was hired, because the engineer had said this had lasted for 2 months, 23 days, 51 days, 81 days, right? The reason why that's important is because the homeowner's insurance policy had an exclusion that if you suffer a water leak or water damage and you don't inform the insurance company within 14 days of the incident happening, they don't have to cover you. So essentially, this engineering firm was hired to prove, using science, that the water had been exposing the house and had been leaking in the house for more than 14 days. Never mind the fact that the guy had a flight ticket and a dated flight ticket when he left town, and the date of the phone call, and these things were only 7 days apart from each other. Never mind all that, right? We're gonna follow science over common sense and actual factual information like dates and records, right? So when we're debunking junk science, part of what we're looking for is reproducibility. If you're going to read a scientific study on how to do something, they need to disclose enough of how they did their study that I could recreate that study. And we kind of talked about some of the things information I'm lacking. Well, how long did you keep it wet? How long did you keep it dry? So, if I don't have these design constraints and I don't know this in your study, I can't reproduce your study, okay? The second thing is the conclusion substantiated? So in other words, the conclusion of that study, which I didn't show you, but just the study, not the engineering report, but the study that the engineering report referenced, said that you can use this information that we've discovered, the pictures of the water damage on the tack strips, the pictures of the mold growth. You can use this information to substantiate your own findings in the field. And they specifically say at the end of the study, in order to, verify, and I'm paraphrasing here, to either verify or debunk or whatever claims of duration. So the whole purpose of the study was to study duration, so that when you go out to a job site, you can say, well, that doesn't look like this picture in the study, so therefore, but it does look like this picture in the study, which is 51 days. So they essentially designed the study, and they designed the study in an air-conditioned space, cooled space with a low relative humidity, low moisture content, so that the mold would grow very slowly and that the water would damage very slowly. so that when they walk out to jobs and properties, like my client's property in this case, and they look at a property that absolutely they know does not meet the design criteria of their study, they'll still quote their own study and say that oh yeah, this has been here for 81 days. So the question question number 2 when you're debunking junk science is the conclusion substantiated? Again, their conclusion being that you can use this data to evaluate things in the field and prove people wrong. It's not substantiated. That conclusion is not substantiated based on the study that they did. Absolutely. And then the third thing you always have to ask yourself when evaluating junk science is, what is the motivation of the person not only creating the junk science, like the junk science study, but then using the junk science to prove a point. And I like this excerpt from Wikipedia regarding junk science, and it says junk science usually conveys a pejorative connotation, so a negative thought process here, negative response, that the research has been untowardly driven by political, ideological, financial, or otherwise unscientific motives. And the thing that I find the most interesting, and one of the reasons I took on the case, was when I looked at the engineering firm, who I'd never heard of at this time, and I looked at the engineering firm and I went to their website, I noticed that all of their clients and all of the work that they do is for insurance companies. So they're essentially hired guns that are brought out to get insurance companies out of having to pay claims. Now they'll tell you, oh no, we do everything, on the up and up, and we're, if the insurance company, if they owe, they owe. We're gonna put that in our report. But the reality is that I've seen these engineering firms, and when they start getting honest, the insurance companies let them go, and they go get a different engineering firm, one that will tell them what they want to hear. So anyway, this was sort of one of the first forensic cases that I had taken on. It was a big job for me. I really didn't charge them nearly what I should have, but it was a learning experience for me many years ago, and it sort of it got me excited about not that there was these bad things going on, and that this poor person homeowner was kind of getting disenfranchised, if you will, out of getting his insurance claim covered. But what really excited me was that I realized I had the tool set to kind of figure these things out and help people. And so that's really what this is all about, is trying to help people, help you guys, help the public, and help our clients. And hopefully there's something in here you guys have learned that you can maybe apply to your own lives or your own cases or your own issues. And what I'd love to do is hear from you guys in the comments, or email us, hit our website up, whatever it takes, and let us know what other things you'd like to see. I have a bunch of these kinds of cases. Some of them are even more interesting and more egregious than this. This one was particularly interesting because it utilized a lot of junk science, but I have other ones that just simply utilize more forensics and drawing different conclusions based on different levels of expertise and training. But anyway, we'll dig into those. But I look forward to the next time we all get to talk, and let me know what you think.